Okay, our final example for today is a definite integral. Once again, we begin by fully factoring our denominator. Remove the common factor of x. Then recognize that this is a difference of two perfect squares, and therefore its factors will look like this: x plus 1, x minus 1. So this will now be our new denominator. Okay, you can see that we will require 3 partial fractions in order to solve this. We will need denominators of x, x plus 1, and x minus 1 respectively. And the numerators here will be a, b, and c. We now add these fractions, which means moving to a common denominator. Okay, a needs to be multiplied by both x plus 1 and x minus 1. Move on to plus b, which will be multiplied by x and x minus 1. Lastly, plus c, x plus 1, like this. We use this long expression now, equating it to the original numerator. From this, we will find values of a, b, and c. The numbers we substitute will give us zeros here, here, right? Everywhere. Okay, so we're gonna use x is 0, x is negative 1, and x is positive 1. Start with 0. Substituting 0 on the left gives us negative 1. The only non-zero term on the right will be here. It will be a times 1 times negative 1. From here, we can see negative 1 is equal to negative 1a, and that means a is 1. Next, we'll substitute x is equal to negative 1. So on the left side, 3 times negative 1 minus 1 will give us negative 4. On the right side, the non-zero term will be this one, b times negative 1 times negative 2. So negative 4 is then 2b, and from that, b is negative 2. Lastly, we substitute x is 1. On the left, that will be 3 minus 1, or 2. On the right, of course, substituting 1 here makes this term 0. Substituting 1 here makes this term 0. The only non-zero term is at the end, c times 1 times 2, from which 2 is 2c, and therefore c is 1. We will go to this form now, substituting our values for a, b, and c, and then integrating. So 1 over x negative 2 over x plus 1, and 1 over x minus 1. A reminder that this is a definite integral. Integrate each. We're going to have ln x minus 2 times the ln of x plus 1 plus the ln of x minus 1. Normally plus c, but it is a definite integral. We're going to combine these now. So first, we can move our exponent. We're moving our coefficient. It becomes our exponent. Combine now into a single logarithm. Which terms would be in the numerator? Those preceded by a plus sign. So x multiplied by x minus 1. The only term in the denominator is the one preceded by the negative sign. So here is where we will have x plus 1 all squared, like this. Okay, and again, a reminder that we still have to evaluate between 3 and 2. So in fact, what we do now is substitute 3 first. And when we do that, it'll look like this. 3 times 2, 4 squared, right? Minus, because it's upper limit minus lower limit. Now we substitute 2. 2 times 1 over 3 squared. Or, in other words, what do we have? We have the ln of 6 over 16, which is the same as 3/8, minus the ln of 2/9. And this you can just put into your calculator carefully. So I'll leave you to try that. You should get approximately 0.523. Okay, there are 3 questions that I need you to try now. They are in your textbook.